Welcome friends to System Design Interview Toolkit Part 2, and today we are going to talk about a very interesting calculation or tool which is request per second. So I will talk about few use cases first when we will require this kind of calculation. So you would have seen a situation where someone will be asking you, okay, if your application is handling or getting 50 billion users request per day, then you have to tell how many server instances will be required, right? So let's say you are having application A, and that application A will get 50 billion users per day traffic. So and your application can handle, let's say, 1000 requests in one instance, right? So to handle 50 billion requests, how many instances will be required? This is one of the use case. Then there might be another use case where you will be writing a JMeter script for doing a load testing, and for example you will be getting 3 million notifications per day. So to do that load testing, you will calculate request per second so that you can write that script. You will try to simulate that much traffic load. So this is very essential calculation which we do in everyday life, right? So to do this, I will just first going to share the trick. While calculating the number of seconds in a day, we are not going to take the actual numbers, which is 86400 seconds. Instead, we are going to bump up this number, and we are going to use this 100,000 or 10 to the power 5. So whenever we are going to say, okay, how many seconds are there in a day, then we will immediately know, okay, 10 to the power 5 seconds are there, because all the calculations are approximate. So we are going to use this 10 to the power 5 seconds. Now I am going to share a magic formula which I use while doing this calculation is 10 into 10 to the power minus 6. So when I am calculating request per second, how I calculate is I always multiply request per day by 10 into 10 to the power minus 6. Why I do so, I will tell you in the next slide. But here I am always try to keep this number, the power, in the multiple of 3's, either 10 to the power 3, 10 to the power 6, 9, in that form. And why I do so? Because it makes the calculations very easy. So let's try to understand how I came up with that formula. So if I have to calculate request per second, what we usually do is we take how many requests per day we are going to get, and then we divide those requests per day by the number of seconds in a day, right? So in our case, we know, okay, we are going to have 10 to the power 5 seconds in one single day, right? So we are going to divide. Can we write it in this form? 10 to the power minus 5 into how many requests per day we are going to get, correct? We are just going to, instead of divide, we are going to multiply it. And can I do one more representation of this previous statement or expression? We will multiply this previous expression by 10 and just increment this by minus 6, right? So 10 into 10 to the power minus 6 into number of requests per day. So this will become our base formula. We are going to use this base formula for calculating request per second for any instances. So as I previously mentioned, since the multiple of 3 makes the life easy, that's why we are going to transform this formula. And I will show you few examples how it is going to make the life easy. So first example is calculate how many requests per second a system needs to handle if 1 billion users are accessing system per day. Okay, so here we are going to get the traffic of 1 billion users So how to represent this 1 billion user? You would have already seen in my previous video. We can represent 1 billion as 10 to the power 9. Correct? What was my formula in the previous slide? My formula was we need to multiply 10 into 10 to the power minus 6 by total number of requests per day. If you see here, I know this value. This is 10 to the power 9. This is 10 into 10 to the power minus 6. What will be my next step? I can do like 9 minus 6, which is 10 to the power 3. I can write it as like 10,000. Correct? Because 10 to the power 3 is equal to 1000. So it will become 10,000. So I can easily tell, okay, to handle 1 billion users per day, I am going to get approximately 10,000 requests per second. 10,000 requests per second. Correct? Now let's take some more example. Instead of 1 billion or 1 million, we are just trying to do the calculation for 30 million users. So if we are having 39 million of users, so how we are going to do the calculation? Same. We are going to first write 10 into 10 to the power minus 6, which is our base formula. Then multiply it with the number of requests. How many requests we are having? Million. If you see here, 10 into 10 to the power minus 6 into 39 into how to represent million? We can represent it by 10 to the power 6. Correct? We can just cross it off. It will be 390 requests per second. Correct? Let me tell you one more thing. Here we were talking about this use case where we need to calculate how many server instances will be required. So since we know how to calculate request per second, so using that, how we can estimate how many server instances will be required, we'll try to calculate that. So my considerations is my one application instance can handle 1000 requests per second. Okay. Now I need to estimate for handling 50 billion requests per day, how many server instances will be required. So first thing is I need to calculate what is my total traffic. This is my per application instance, how many requests I can handle. But I need to estimate how many requests I am actually getting so per second. So how I am going to do? 10 into 10 to the power minus 6 into 50 into billion. How to represent billion? 10 to the power 9. Is it okay if I will write it at like 10 into 50 and I will just do this calculation? So 9 minus 6 is 10 to the power 3. This will become 500. This will become 1000. So I am going to have 500,000 requests per second. Now let's say if I have to calculate how many server instances will be required. So for doing that, how I am going to do? Again, I am going to just take the same number. I know this 500 into 10 to the power 3. I am going to divide it. And you know, I can round it off. So 500. So this is the number. These many numbers of servers I will require for handling 50 billion requests per day, considering my one instance, server instance, can handle 1000 requests per second. Okay. So that's how we are going to calculate. So I'm just going to give you one example. So before that, I'll just walk you through with this chart, which I prepared using the same formula. So here we can see in this first column I am going to keep how many requests per day our system can handle, or we are going to get the traffic. And then this is the second column where we are going to use the same formula which I came up, and then we will see how many requests per second actually we need to handle. So if you see 1 peta, how to represent peta? 10 to the power 15. If you use the same formula, just replace this request per day, 10 to the power 15 minus this 6 from 15, you will remain with 10 into 10 to the power 9. 15 minus 6 is 9. So it is, 10 to the power 9 is 1 billion. It is 1 billion, and you will multiply it by 10. So it will become 10 billion. So that's how very easily we can get this number. 1 trillion. How to represent it? 10 to the power 12. We will use the same formula. We'll just replace the request per day. 12 minus 6, remaining 6, 10 to the power 6. It is 1 million. Then it will become 10 million. So to handle 1 trillion requests per day, we need to handle actually 10 million requests per second. Easily we can calculate it, correct? Similarly, for 1 billion, we are going to replace this with 10 to the power 9. 9 minus 6 is 3, 10,000, right? And 1 million is total 10 requests. So using this formula, you can very easily find out how to do this. Okay, let me take one more example here. Say 560 billion requests per day, and we need to convert it into request per seconds. Okay, so from our formula we can write it like 10 into 10 to the power minus 6 into, we can split it into 560 into 1 billion, and how to represent 1 billion is 10 to the power 9. Okay, so we'll just multiply these numbers, 560, add one more 0, then we can just reduce 6 from 9. Okay, then it will become 10 to the power 3. Whenever you will see an opportunity to convert a number into multiples of 10 to the power 3, then you should always do that for making life easy. So how we can represent this? 5.6 into 10 to the power 3, and then we will just note down this 10 to the power 3. It will become 5.6 into 10 to the power 6, which is, we know, is 1 million. So we can say our answer will be 5.6 million. Okay, another good thing which we can do here is, during the calculation, we can upscale the number. So whenever we see, okay, there are some decimal points are coming, we can always upscale those numbers. So instead of taking this 5600 here, what we can do, we can say, okay, 6000 into 10 to the power 3. Okay, and then this will become 6 into 10 to the power 3, and we will note down this 10 to the power 3 here. Okay, it will be 6 into 10 to the power 6, which is 6 million. Okay, since these calculations are approximate number, and we can always upscale them, so this will become our answer. I will give one problem here. You may try to solve this and try to write your answer in the comment section. So let's say you are going to have 230 peta request per day in your system. Okay, and you need to calculate how many requests per second your system has to handle. So you need to calculate number of requests per second. So try to do this exercise and write your answer in the comment section. We'll see in the next video. Thank you.